Hole 1 with a lime cement plaster, being moved by gantry into position at the fire chamber. As very specifically proscribed in the test procedure, thermocouples are attached to the wall in 9 locations spread around the opposite side of the 10-foot by 10-foot fire opening. The temperature reading at any of these points cannot rise by more than 250 degrees Fahrenheit, which never proved to be an issue. The biggest temperature rise was less than 100 degrees. The test begins with the firing of high-intensity gas burners in the chamber, aimed parallel to, not at, the wall surface, as seen here through one of the many glass viewing ports. Within about 20 minutes, the plaster has begun to crack. On the outside, both steam and smoke begin to emerge from cracks. The steam is from moisture in the bales and plaster. The smoke is from the straw charring at the cracked plaster in the chamber. After 2 hours, the burners are shut off, and the wall is unclamped and removed as quickly as possible from the fire chamber. With the release of the clamping pressure, the remaining burnt plaster falls away from the straw, and the sudden rush of oxygen feeds a brief burst of flames. The flames quickly die down, leaving a surface of charred straw to face the hose test. The hosing, like the burning, is very specifically defined by the test protocol, passing back and forth and up and down across the surface of the burnt wall. Some leakage is allowed, but the hose stream itself cannot penetrate at any time during 2.5 minutes of hosing. The difference between the burnt and the unburnt surface is striking. When plaster was removed from the non-burned side, the bulk of the straw was found to be uncharred. This showed that bales behave like heavy timbers in fire, in that the surface will char and then insulate and protect the fibers beneath the surface.